Hi, now we are going to see what is skim cut, what is tab, and what is the skim cut, what is lead in and what is lead out, how to do the overlap. Uh, about all this we are going to see now. Okay, so now we'll start with the basic toolpath. So first of all we'll see the lead in lead out. So I just change the lead in lead out into line and arc. And also in exit I make it line and arc. So I keep overlap distance at 2 mm. Just to see and regenerate and see. Now you can see that. So this is called the overlap distance. If you see from the top view, so this is the overlapping between the entry and exit. Okay. So what is the advantage of this overlap? So from the entry point, if you move little forward and uh, uh, exit, that leads to avoid the wire marking. If you the same place, if you do lead in and lead out, there may be chances of a wire mark on the entry point. To avoid this, we are adding the lead in lead out. If you want, you can change the distance and angle, whatever you want. Now you can see that with radius and now you can see that by doing this you will not get any wire mark on the entry point of the wire. Now we are seeing uh, what is the lead in lead out and what is the purpose of overlap. So what is the advantage of doing the overlap? So next we will see the skim cut. What is skim cut? एक बार cut just after one time if you cut, then the next cut it will do it. So you can see rough cut and skim cut there. So just we'll simulate and see. This is your roughing cut. You can say that the skim cut is a finish cut. You can say that. So this is the second one is called the skim cut. So it's like after roughing cut you are doing one finishing cut. It's similar the sometimes people does the skim cut in the reverse direction. You can switch over the skim cut direction. So at present roughing we are doing it the clockwise. So then the skim cut should be in the anti-clockwise direction. Let us see after simulation. This is roughing is happening in the clockwise direction. Now you see this is the anti-clockwise it is happening, the skim cut. As I said earlier, skim cut you can say that this is the finishing cut. Now we have seen what is rough cut, what is the skim cut. You can change the skim cut more than one skim cut also. So suppose if I don't want now a skim cut now, then now we'll see about what is the tab. Suppose my cutting starting here, and it is starting cutting. So one just imagine. So the after cutting this up to that near to that entry point, so you can see that the load of that slug will comes down. So that leads to problem. So it need to be supported. So it need to be supported either by gluing or providing the tab. So otherwise, so people used to do gluing. They will stop in between. They will add some glue and fix that one. So otherwise, if you are not doing gluing, otherwise you can do the tab also. Then that is the foam metal support. If you do gluing, then no need to do the tab. But if you want to do, if you are doing tab, that gluing is not necessary. It is left to you how you are managing the situation. Generally, they will stick with the Fevikwik with uh, some metal. They will have a glue, then fix with the slug, so that it will not fall down while cutting. So next we'll see the how to make the tab cut. I'll select some position. One more tab cut here. I have done two tab cut. If you want, you can add one more tab cut. I think the tab width is too less. Let us see after generating. So this is the together cut. That after tab cut, you can have one more skim cut. But here at the beginning, skim cut is not necessary. So now I just added one skim cut at the bottom. This is called the together cut. Okay, uh, but tab is happening, but with this is washed away now. So I think we need to change the tab width. Um, Let us change the tab. Um, I think I should have given this tab width at the beginning only. Uh, but if I give it now, whether it will accept or not, let me see. Okay. Okay. I'll change the tab width. Maybe uh, I'll change the tab width. So what? How much we'll give? Definitely, it is more than the overlap distance. Now I'll change the lead in lead out overlap now to minimum. So definitely that tab distance is more than the overlap distance. Okay. Now I'll regenerate. Oh, okay. It is not accepting. So I think we need to um, regenerate the toolpath, or otherwise delete this. Okay, we'll try with providing little more tab width. So let us give 10 mm and see whether it is accept or not. No, it's not accepted. So whatever the tab I given, I think it need to be reselect. Okay, I'll reselect now. Otherwise, do one thing. Right, okay, let us try one more reselecting the tab. Okay, we'll experiment, no problem. I'll go again, I'll reselect the tab. This is my first tab. Second tab. You can see the two white lines are there, so that's the tab width. Okay, let us regenerate. Oh, oh, now, now I think there's 6 tabs. Okay, it's better we can delete and regenerate it. Okay, I'll go again. Wirepath, on to our wirepath. I'll select first the point, entry point. I will select now. Okay, accepted. Then we'll go for selecting the chain. Okay, accepted. So it's better at you need to break at the start point. Okay, so now change the wire diameter 0.2. Okay, uh, cut parameter, one rough cut, and you say or switch on the tab, and you can give the tab thickness. So I give 5 mm. Number of tab cuts manual I have selected. Okay, here one, my second tab, and this is my third tab. Okay, so you can add one skim cut after the tab cut, and you can check if you want to add a lead in lead out in the tab also you can do it. I make overlap very less. I'll give 1 mm. Okay, region. Now you can see it has happened correctly. So it's left the material for tab. Oh, I think I have not given the height and other thing. Okay, I'll rechange the height depth parameters. Okay, I'll change it. Upper wire guide height is 2 mm. Top of stock 0 0, and thickness is minus 25. Lower wire guide is minus 27 mm. So all are in absolute. Okay. Now we'll see by cutting. It's better we can see by back plot. It will give you a good idea than the solid verification. This is our first cut, so it leaves the material for the tab. Okay, next the tab cut. Then this is the together cut. After tab cut, that's the together cut. It is called the final CM cut. Okay, if you want, you can make now solid simulation. Okay, So you can remove chip and see. So I think I did its opposite direction. It removed the wire piece. Okay. So you can change it also. Otherwise close it, and again you can keep or also remove. Both the options are available. Okay. We'll do it in the another time also to check this. Okay, that's not a big issue. So this is all about the skim cut. Still, if you want some additional, you can add the some additional things also here. Uh, Hope you know you understand what is a tab cut, what is together cut, what is a skim cut. So if you want one more additional skim cut, you can do it. Oh yeah, you can give the together cut two pass also. Okay. Next we will see the stop option. You can add on. You can add before each tab. You can add stop option. You can give before tab it is to stop 2 mm. You can regenerate, but you cannot see that in the simulation, but you can see that one in the code. So while generating NC file, you can see that this is your program, and S101 is the condition code. It will depends on machine to machine. So this is for the FONUC machine. Mm, so here that M60, M39, all are there. Now we'll concentrate where the M50, you can see here M50 is a stop. Then you can see M60 is a switching on again. Again cutter compensation is started. Again next tab. Okay, this is your tab position. Stopping before the tab. Okay, so we can send this one to the machine and do it. Thank you.